Drilling fluid, or drilling mud as many people call it, is a vital element of the rotary drilling process. The term drilling fluid includes air, gas, water, and mud. Mud refers to the liquid that contains solids in water or oil. The mud is made up with clay and other additives that give it desirable properties. Often, water is the base of drilling mud. Water makes up the liquid part, or phase, of a water-based mud. Crew members put clay and special additives into the water to make a mud with the properties needed to do its job well. For example, clays give it thickness, or viscosity. The water in the mud may be fresh water, seawater, or concentrated brine, salt water. The one used depends on its availability and whether it gives the mud the needed properties to drill the hole efficiently. When circulated down the drill string and up the hole, drilling mud serves many functions. For example, mud cleans the hole, cools and lubricates the bit and the drill string, lifts cuttings to the surface, carries information about the formations being drilled, stabilizes the wellbore, controls formation pressure, and suspends cuttings when pumping stops. One function of mud is to clean the hole. A clean hole allows the bit to drill into uncut formation rock. Here's an example of what can happen when cuttings are not removed off bottom. Mud jets out of the bit and moves cuttings away from the bottom of the hole. The mud then carries the cuttings up the annulus and to the surface for disposal. Heat is encountered downhole. Deep formations can be very hot, and friction from rotating drilling components generates a lot of heat. High temperatures increase drill string and bit wear. Drilling fluid helps to reduce the temperature in the drill string downhole while drilling. In addition, drilling fluid provides lubrication to the drill string and bit that also helps prevent wear. Mud stabilizes the hole, keeps it from caving in. As mud moves up the hole, it usually flows by permeable formations. Permeable formations are those that allow fluid to flow. When the mud is next to a permeable formation, pressure forces the liquid part of the mud, the filtrate, into tiny openings or pore spaces in the formation. This leaves behind a thin sheath of solid particles, known as mud cake. These solids plaster the side of the hole, much like the plaster on the wall of a building. The wall cake helps keep the hole from caving in. The column of mud in the well creates pressure downhole, called hydrostatic pressure. The hydrostatic pressure of the mud column offsets formation pressure. Mud is the first line of defense in well control. As long as the hole is full of mud that is the right weight, the well cannot kick and perhaps blow out. A kick is the entry of formation fluids into the wellbore. The kick forces drilling mud out of the hole. If crew members fail to control a kick, a blowout can occur. A blowout is the uncontrolled flow of drilling mud and formation fluids out of the hole. Mud is also used to obtain information about formations downhole. Mud loggers, by examining cuttings at the surface, can gather important information about the formation being drilled and the conditions downhole. The rig uses many pieces of equipment to circulate and treat or condition the mud. Mud circulation begins here, in the mud tanks, sometimes called the pits. Crew members prepare the mud in these tanks and make it ready for circulation. The heart of the circulating system is the mud pump. Often, rigs have two pumps, one primary pump and one for backup. Or, if hole conditions require it, the driller can compound or combine the two pumps to circulate large volumes of mud. In fact, on deep wells, the rig may have 3 or 4 compound pumps. The powerful pump or pumps pick up mud from the mud tanks and send it to the drill string and bit. The pump moves the mud into the discharge line, up the standpipe, and into the rotary hose. The standpipe takes the mud about halfway up the mast. The rotary hose is attached to the standpipe. The rotary hose is strong, flexible hose that moves with a swivel as it goes up and down in the mast. From the rotary hose, the pump moves mud through the swivel and then down the Kelly and drill string. On rigs with a top drive, the mud moves through a passage in the top drive and then into the drill string. The pump moves the mud down the drill string to the bit. At the bit, the mud jets out of the openings or nozzles in the bit. The jets of mud move cuttings away from the bit. Mud then continues up the annulus, carrying the cuttings with it. From the annulus, the mud with the cuttings in it goes through the return line, sometimes called the flow line, to the shale shaker. The shale shaker removes the cuttings from the mud. The mud then falls into the mud tanks, where the mud pump can pick it up and continue the circulation process.